Hi kids, so in a previous video of class 9, we have solved sums till sum number 18 of exercise 16.4, surface area and volume of solid, ML aggarwal. Look at sum number 19 now, okay? A field is 30 meter long and 18 meter broad, a pit 6 meter long, 4 meter wide and 3 meter deep is dug out from the middle of the field and the earth removed is evenly spread over the remaining area of the field. Find the rise in the level of the remaining part of the field in centimeter correct to 2 decimal places. I'll just draw the diagram. So what happened? You have a rectangular field that's 30 meter long and the breadth is 18 meter. Now in the center, you dug a pit, okay, which is 6 meter long, 4 meter wide, and the depth, is 3 meter. So you take out the earth from it and evenly spread over this remaining area. So the level of this area will rise. They've asked for that rise in level. Okay. Now, first of all, the volume of pit. Volume of pit. Suppose V1 is length into breadth into height. Meter cube. Done. Okay, when the pit is formed, we need to find the area of the remaining field. Area of the field without the pit. Without pit. It will be, 30 into 18, length into breadth, minus area of this pit, which is 6 into 4. Am I correct? That's 540 minus 24, that's 516 meters square. Now suppose the increase in height is when the earth is put all around it, the increase in height is h. Let the increase in height be h. Then, therefore, volume of earth spread will be area of the remaining field multiplied by the height, isn't it? Volume is area into height. Now this volume and this volume has to be same because the earth has been removed from this portion only and spread evenly. So according to the problem, we can say 516 into h is equal to 6 into 3 into 4. Am I clear? So height is 6 into 3 into 4 by 516 for 1 times, for 1 times, for 2 times, for 9 times. Am I correct? Yeah. 3 1 time, 3 43 times. So that's 6 by 43 meter, which is, if you calculate, 0.1395 meter, which you can say 13.95 centimeter. Clear? Pretty easy. Just find the volume of the pit, volume of this, the earth, when it is spread all over the field, apart from this region, equate it, you'll get the answer. That's 13.95 centimeter. Now let us look at the next sum. Now look at this sum, sum number 20. Similar to what we did in sum number 19. A rectangular plot is 24 meter long and 20 meter wide. So there's a rectangular plot which is 24 meter lengthwise and 20 meter breadthwise. A cubical pit of edge 4 meter is dug at each of the 4 corners. So at each of the 4 corners, a cubical pit is made, okay, with side 4 meter of the field, and the soil removed. You remove the soil from here and evenly spread over the remaining part of the plot. By what height does the remaining plot get raised? Similar to the previous one. First, find the volume of the pit. Volume of one pit, since it's a cube, okay, of h 4 meter, so it will be 4 into 4 into 4. That's 64 meter cube. That's the volume of the soil removed from one pit. So volume of 4 pit will be 4 multiplied by 64 meter cube, isn't it? Now when the pit is formed, the area of the remaining field, area of remaining field, that's area of the rectangle, which is 24 multiplied by 20 minus 4 times the area of the square, okay, which is area of the square is what? Side into side, which is 4 into 4, isn't it? Area of the rectangle is length into breadth minus 4 times area of each square is 4 into 4, isn't it? So that's how much? That's 480 minus 64. That's 416 meter square. Now suppose when the soil is spread, the height is h. Let the rise in level, okay? Let the height be h. Then volume will be what? Volume of this, when the soil is spread, the remaining part, the volume of that part or the volume of the soil which is spread will be equal to area into height, isn't it? Volume of the soil spread over the remaining portion is nothing but 416 into h. Now this volume and this volume has to be same, no doubt. So 4 into 64 is equal to 416 into h. So your h is 4 into 64 by 416. Am I correct? For one time, 104. For 16 times, this is for 2 times, 4 2s are 8, 4 6 are, then 2 8s are, and then 2 13s are. So that's 8 by 13 meter. So this will be the height. Am I clear? Same. Find the volume of the soil removed. Find the area of the remaining portion when the pit is formed. Find the volume of the soil spread. That will be area into height. Equate it. You'll get the answer. Done. Now let us look at the next sum. Now look at sum number 21. The inner dimensions of a closed wooden box are 2 meter, 1.2 meter and 0.75 meter. The thickness of the wood is 2.5 centimeter. Find the cost of the wood required to make the box if 1 meter cube of wood cost rupees this. So there are two cases. See, inner dimension when you talk about the wood and outer dimension of the box, isn't it? Because when you imagine a box, the wood has some thickness which divides the entire solid figure into two parts. The inner cube, you can say, and the outer cube. Inner dimension and the outer dimension. Just imagine, okay, which is something like this. See, if you see the top portion is something like this, isn't it, of the box? So there is inner dimension and there is outer dimension. Am I clear or not? It's closed. I've shown you an open box. Okay. So first of all, so volume of the wood in this case will be the outer dimension, the outer volume rather, minus the inner volume. Okay. That will give you, if the outer volume, you subtract the inner volume, you get the volume of the wood required, isn't it? So first thing what we'll do, inner dimension is what? Length is 2 meter, breadth is, I'll write small l and b, small l, small b, that's 1.2 meter, and the height is 0.75 meter. But when you talk about outer dimension, look over here, outer. So we'll add 2 times the thickness, isn't it? So inner dimension plus, first of all, convert this into meter. So that's 2.5 divided by 100, that's 0.025, isn't it? Meter. So twice into 0.025. Am I correct? So that's twice plus 2 plus, this is 0.050. So that's 2.050. Similarly, the breadth will be 1.2 plus this factor only. Am I correct? That's 1.250. And the height will be 0.75 plus 0.050. So the height is 0.80. These are all in meter. Am I clear? We first need to get the volume of the wood required, okay? Now, the inner volume. The inner volume is length into breadth into height. And the outer volume is length into breadth into height. Am I clear? Meter cube. So if you look, 1.25 into 0.8 is nothing but 1. 1 into this will be 2.050 meter cube. Am I clear? And this is 2.4 multiplied by 0.75. That comes as 1.80. So that's 1.80 meter cube. So the volume of the wood is outer minus inner. Outer volume minus inner volume. That's how much? That's I think 10 minus 2 is 10 minus 8 is 2. 0.250 meter cube. Now 1 meter cube costs rupees 5400. So cost of this much, cost of 0.250 meter cube. What do? You simply multiply it with 5400. So that's 0.250 multiplied by 5400. Isn't it? Just solve it. You'll get the answer. Clear? Get the outer volume, get the inner volume, subtract. You'll get the volume of the wood required. Once you get the volume, you multiply by rupees 5400 because 1 meter cube is this much. Clear? Pretty easy. Now let us look at the next sum. Now look at sum number 22. A cubical wooden box of internal edge 1 meter is made. So inside, if you see the box, it's a cube, okay, of 5 centimeter thick wood. The box is open at the top. So the previous sum and this sum is same, slight difference. This box is open at the top. The previous one was closed at the top. If the wood costs rupees 9600 per cubic meter, find the cost of the wood required to make the box. Very simple. See, there are two things. Internal dimension and external dimension. Isn't it? Internal dimension is a cube of 1 meter edge, which means if I say length, breadth and height will be same 1 meter. But when you consider the external dimension, length, breadth and height, just look carefully. First of all, when it comes to length, 1 meter plus twice into the thickness of the wood, that is 5 centimeter is 0.5 centimeter is 0.05 meter. So twice into 0.05, that's 1.1 meter. Similarly, breadth will be 1 meter plus twice into thickness, that's 1.1 meter. But when it comes to height, since the box is open, so it will be internal plus 0.05, the thickness, not twice, because the topmost portion, when you see it from the top, something like this. For the length, you add twice the thickness. For the breadth, you add twice the thickness. But when it comes to height, only one time the thickness. Is it clear? If it is closed, then twice the thickness of the wood. Now, we'll get the volume in each case. Volume internal, that's 1 into 1 into 1, that's 1 meter cube. Volume external, that's 1.1 multiplied by 1.1, and this is what? This is 1.05 meter. So that's 1.05 meter cube. Isn't it? Now 1.1 into 1.1 is 1.21. Into this 1.05, it will be 1.2705. I've done this calculation earlier, okay? This is done. Now with the volume of the wood. Volume of the wood is external volume minus the internal volume. That's 1 in this case. So that's how much? That's, if you look, 0.2705 meter cube. So the cost of the wood will be the volume of the wood multiplied by the rate. Rate is how much? Rupees 9600. Just multiply this, you'll get the answer. Done. The most important part was, in case of the open box, height, suppose you're finding the external, will be internal plus 1 times the thickness, while the length and the breadth will be 1 plus twice the thickness. Am I clear? And if it is closed, then here also height will be 1 plus twice. Suppose if it is closed. Okay. Now let us look at the next sum. Now look at this sum. 23. A square brass plate of side x centimeter is 1 mm thick. So you have a brass plate of side x centimeter in a square, and its thickness, if you talk about thickness, it's 1 mm. 1 mm means 1 by 10 centimeter, isn't it? And weighs, the weight of this is 4725 gram. Okay. If 1 centimeter cube of brass weighs 8.4 gram, find the value of x. Very simple. First of all, find the volume. Volume will be what? Length into breadth into height. That's x square by 10 centimeter cube. Done. Now look carefully. Unitary method. 8.4 gram is the weight of 1 centimeter cube. They have given. So the weight is 7425 gram. 7425 gram is the weight of 1 by 8.4 into 7425 centimeter cube. That's 562.5 centimeter cube. That's the volume. Now this volume and this volume are same, so we can equate it, isn't it? So we can say x square by 10 is equal to 562.5, which means x square equals to 5625, which means x equals to 75 centimeter, which means the side, find the value of x, is 75 centimeter. We just got the volume, length into breadth into height. Then by unitary method, you got the volume. Equate it, you'll get the answer. Simple. Now let us look at the next sum. Now look at this sum. 24. Very easy. 3 cubes of edge x centimeter, 8 centimeter and 10 centimeter respectively are melted and recast into a single cube of edge 12 centimeter. Find x, which means we have 3 cubes of side x centimeter, then 8 centimeter, then 10 centimeter, isn't it? What you did, you melted all 3 and you got a larger cube. I'm drawing one face of the cube, okay? Or 12 centimeter. Then find x. Very easy. The volume of these 3 added will give you the volume of this, isn't it? Volume is constant. So V1 is x cube, the volume of this one. V2 is 8 cube, that's 512 centimeter cube. V3 is 10 cube, that's 1000 centimeter cube. And V4, suppose, is 12 cube, that's 1728 centimeter cube. Now, according to the given situation, x cube plus 512 plus 1000 equals to 1728. That's x cube equals to 1728 minus 1512. So x cube will be 216. 216 is the cube for 6. 6 cube is 216, which means x equals to 6. Or you can find the cube root of 216. Cube root of 216, we know That's 2 into 2 into 2 into 3 into 3 into 3. That's 6. 2 will come out and 3 will come out. Or we can do like this also, indices property. If the powers are same, the base is the same. That very easy. So x is 6 centimeter. Okay, just add the volume, equate it with the volume of the cube with side 12 centimeter. Clear? Now let us look at the next sum. Now look at sum number 25. Very interesting. The area of cross section of a pipe is 3.5 centimeters square and water is flowing out of the pipe at the rate of 40 centimeter per second. How much water is delivered in 1 minute? Suppose most of the pipes are, cylindrical in shape. Suppose water is flowing through this pipe. Area of cross section is given to us. That's how much? That's 3.5 centimeters square. And the speed at which the water is flowing is 40 centimeter per second. So suppose from here to here, the length is 40 centimeters. Suppose. Then this much of water comes out of the pipe in 1 second. Am I clear or not? Try to understand. If I take from here to here as 40 centimeter, then this much of water comes out of this pipe in 1 second, which means volume of water flowing in 1 second is nothing but volume of this part, which is volume is how much? Cross section area into the length, remember? So cross section area is 3.5 and the length is what? 40. So that's 35 into 4, isn't it? That's 140 centimeter cube. So this much of water comes out in 1 second. So volume of water flowing in 1 minute, they have told. We'll just multiply this by 60. That much centimeter cube. You can leave the answer like this, or you can give the answer in liters. How to convert this in liters? Centimeter cube to liters, you divide by 1000. So that's 140 into 60 by 1000 liters. So 6 times. That's 84 by 10. That's 8.4 liters. So this much of water comes out of this pipe in 1 second. Clear? Very easy. We have done it in the previous video, Volume is given as area of cross section into the length. Okay. So with that concept, we got the volume of water flowing out in 1 second. Once you got that, in 60 seconds, you will get the volume. So in this video, keep it till here. In the next video, we'll solve the rest of the sum. Till then, take care and do subscribe the channel. And if you like the video, don't forget to press the like button. Take care.